In a simulation model, we have both input information and output information. Regarding the input information, we have two different sources of information. Those elements which are related to the things that the decision maker do not control are those described as variables. For example, in our case, we do not control the inter-arrival time between customers. In other contexts, that might not be the case, and if we offered some discounts, we might change that. But we are assuming in our first analysis that this is not something we cannot control. But we need to introduce the right information regarding how often or what is the time in between every two customers. Second, we also have design parameters, which is the information that reflects the things we can change in our real system and over which naturally we have control. And we need to explore, or we want to explore, different values for these design parameters. In our case, that was the number of operators and the number of dispensers. And as results of the values for input variables and design parameters, we have output information, which is the value for the output variables. So in our case, that was the income we obtained, for example, or the utilization rates for our resources, such as the operator and the dispensers. So in this figure, what we have in this image, we have input variables and design parameters as input information and output variables as output information. But notice that what we have is that typically in a discrete event simulation analysis, what we have is non-deterministic variables, which means that we don't know for sure, as it was the case in the gas station, the time between two customers. So every time we run the model, we're going to use a different set of input variables, which combined to our design parameters allows us to replicate several times how the system would behave for these design parameters, getting output variables. And for each set of values of input variables, we have a set of output variables. So we need to analyze this carefully so that we do not just run once our model and get the results out of it, just get that result as the good output or the good KPI that allows us to estimate how our system will behave. We need to do that several times. How many it is something that I'm not going to cover in this playlist, but of course, if you go to law's book, you'll find that, or any introduction on simulation. But I want you to keep in mind that it's not, the simulation is not just a coding exercise where you just make a nice model and you run it. You need to take care of how you feed it, and for every set of input variables you have this output, and you need to carefully analyze what comes out of it.